Hi, in this video I'm going to show why the motion of vertical spring is exactly the same as the motion of the horizontal spring. It's affected by the spring restoring force only, and it's not affected by the gravity. Let's look at this picture. We have a spring in a stretched position and then stretched with the mass attached to it, where dotted line represents the equilibrium position, and the second distance L2 is the distance from the equilibrium position where the spring was pulled by a hand. Now let's consider the forces acting on this mass in the equilibrium position. The force of gravity downwards is balanced by the force of the spring. We can write this equation. Force of the spring equals the spring constant multiplied by the L1, which is the stretch distance from the unstretched spring, and it equals to the force of gravity mg. So the L1 distance is mg divided by the spring constant. In the other position right here, we can write the balance of forces for this position right here. The net force is going to be this spring force, which is the sum of the two displacements L1 and L2 multiplied by the spring constant, minus the force of gravity, which is mg. It's the same force, right? It's going to be downwards, but the net force is going to be upwards, so that's why it's the spring force minus mg. But let's look at what the spring force is equal to at this position. It is equal to the k times L1 plus L2, but L1 can be substituted from the first equation that we derived earlier, which brings us to the k constant cancels out for the first term, and we have the force of gravity plus the KL2 for our spring force. When we substitute the spring force into the net force equation, we can see that the force of gravity mg cancels out. Therefore, we can say that the net force is only equal to the K L2, and it equals to the spring force. Therefore, the motion of the vertical spring happens under the spring restoring force only, which is identical to the motion of the horizontal spring. Thank you for watching.